To achieve net zero emissions, a significant effort will be required to discover, improve, and implement climate solutions that are specifically tailored to expedite decarbonization. According to research, in order to attain net zero emissions by 2050, yearly production of pure hydrogen, a low-carbon energy carrier, will need to increase more than sevenfold. According to one research, worldwide capacity for long-duration energy storage, which supports the use of renewable energy, must expand by a factor of 400 by 2040 to assist the power industry in reaching net zero by that year. Renewables, solar, wind, offshore and onshore, grid upgrades. Solar and wind energy are going mainstream, and they will cover most of the energy needs of the world soon. These technologies are improving and getting more compact to be included everywhere. Grid systems will be upgraded to transfer and store renewable energies. Solar cells can be infused into windows, walls, and exteriors of buildings soon. Solar nanotechnology may be introduced one day to convert any surface into an energy generator. Wind turbines can generate more power than large areas covered in solar panels. Deserts and cities can be covered in solar panels. Buildings will be clean energy powerhouses when renewable energy is incorporated into every component of every building. A green energy grid will connect the whole world, since some areas can generate more energy than others and transfer them to the global grid. Batteries and energy storage, electric vehicle batteries, long-duration energy storage. Lithium-ion batteries are the best batteries for electric vehicles and energy storage at this point. Battery technologies are improving. Companies want to find alternatives to cobalt and nickel that are rare and difficult to process. Sodium-ion may be the best option to replace lithium soon. Batteries and renewable energy storage will be integrated into most vehicles, transportation systems, the grid, and buildings soon. This is what's needed to reduce carbon emissions from every industry. Batteries will play a great role in reaching net zero. Structural batteries may turn any surface into a battery shell soon. They can be integrated into cars, buildings, and electronics. Since renewables will be everywhere, batteries will support them in storing energy. Lithium and other rare earth, hard-to-process metals and minerals will be replaced with more abundant and eco-friendly methods of battery manufacturing. Circular economy, battery recycling, chemical recycling, energy from heat, plastics. Circular economy is required to reduce waste and mitigate emissions in every industry and city as of now. Recycling is crucial to building a circular economy worldwide. Plastics can either be designed to be reusable or chemically recycled, with new systems turning them into oil under high pressure and heat. Waste heat is emanated from many sources. This can be harvested as a new energy source. This will reduce emissions and utilize it as energy. Plastics and all kinds of waste can be reused for every industry if they're designed to be fully reusable before they're manufactured and sold worldwide. Greenhouse gas emissions can be recycled and synthesized as chemicals, fuels to make many things. Every company can design their products and packaging to be collected and reused by them. This can reduce waste to zero. Every industry, city, and country can achieve a zero waste, circular economy soon if they put in the effort to reuse and recycle everything. Battery recycling will improve every year because the minerals inside batteries are very valuable, and they're going to get scarcer as a result of high demand. Building technologies, geothermal heating, heat pumps, electric equipment. Buildings include a lot of technologies for electricity, lighting, air conditioning, heating, plumbing. Geothermal heating is one of the ways to keep buildings warm efficiently during cold months, without wasting electricity. Geothermal energy can also generate electricity for buildings. Small geothermal systems can be installed underground in buildings and cities. Heat pumps work with electricity, so they don't burn any fuel to run. Buildings will upgrade their electric equipment to support renewable energy and storage. Buildings can generate a lot of energy from renewable sources like solar, geothermal, and even integrated algae biofuels. Biofuel conversion of algae can absorb CO2 from the air, then biofuels generate electricity for buildings. Gas equipment will be replaced with electric in every building to retrofit buildings with net zero systems. Solar windows and panels can work well as walls and clear windows for buildings while generating tons of energy. Every building and housing complex can be retrofitted with new renewable systems in order to reach net zero in a short time. Industrial process innovation, electrification of heat sources, green steel making, green cement, waste processing. Waste heat is one of the sources of high heat that can be harnessed to generate electricity. Heat sources can be electrified with new thermoelectrical devices. These devices convert heat from any source to electricity, and they can be utilized for every industry. There is so much waste heat emanating from every plant, facility, manufacturer, and engine. This can be harvested as clean electricity. Steelmaking is getting greener by capturing the emitted CO2 with pyrolysis. Other industries make use of captured CO2, or store it in cement. Companies and manufacturers are realizing that waste can be one of the greatest and cheapest resources. Resources are getting scarcer and more expensive worldwide. Waste can be processed into new products and materials with a few tweaks in the manufacturing process. Waste is going to be fully reusable one day. Plant-based building blocks can replace concrete to reduce emissions from construction significantly. Hydrogen, electrolyzers, fuel cells, methane pyrolysis. Green hydrogen is harvested by splitting water into oxygen and hydrogen with electrolyzers. This process is emission-free. Green hydrogen can be used for everything, for methanol production by synthesizing it with CO2 from biomass, to generate electricity and to make chemicals and products. Fuel cells can power cars and other systems. Green hydrogen can be produced from collected rainwater in buildings to power entire cities. Green buildings collect rainwater and store it in tanks. Transportation systems, buildings, and facilities can be powered with green hydrogen and methanol when their production is scaled up globally. Some industries emit so much methane. Methane can be captured and filtered to generate hydrogen via pyrolysis. This process can mitigate emissions in industrial facilities. Hydrogen is discharged and stored, while carbon is captured for industrial uses in this process. One of the most potent gases contributing to climate change can be converted into hydrogen and carbon that can be used for many industries. Sustainable fuels, advanced biofuels, e-fuels. Advanced biofuels are fuels that can be made from a wide range of non-food biomass. Biomass in this context refers to plant materials and waste that are especially used as a fuel source. Because these innovative biofuels are made from a variety of feedstocks, they may demand the use of specialized equipment to extract meaningful energy. New feedstocks include plant dry matter or woody crops, agricultural waste or garbage, and specialized non-food energy crops. The goal of new biofuel processes is to increase the amount of biofuel that can be produced sustainably by using biomass composed of residual non-food parts of current crops, such as stems, leaves, and husks left over after the food crop has been extracted, as well as other crops that are not used for food purposes, such as switchgrass, grass whole crop maize, miscanthus, and cereals that bear little grain, as well as industry waste such as wood chips, skins, and fruit pulp, etc. Carbon-based materials can be heated to high temperatures in the absence of oxygen, air, or steam, pyrolysis, or in the presence of oxygen, air, or steam, gasification. These thermochemical processes generate a gas mixture that contains hydrogen, carbon monoxide, carbon dioxide, methane and other hydrocarbons, and water. Solid char is also produced by pyrolysis. The gas can be fermented or chemically transformed into ethanol, synthetic diesel, synthetic gasoline, or jet fuel. Electrofuels, often known as e-fuels, synthetic fuels, are a distinct class of drop-in replacement fuels that are created by storing energy from renewable sources in the chemical bonds of liquid or gas fuels to give a carbon-neutral fuel. They can take the place of biofuels. Other alcohols and carbon-containing gases, such as methane and butane, are viable substitutes for butanol, biodiesel, and hydrogen. Nature-based solutions, protection of forests, peatlands, mangroves, reforestation, agroforestry. There are nature-based solutions to soak in carbon and mitigate climate change. They could be more effective than other solutions because nature works the best. Trees can continuously absorb carbon during their lifetime. Protection of forests is significant to tackle climate change. Some countries are planning to build forest cities that will grow as new forests. Many cities can be remodeled with a lot of trees. Wildfires have shown that forests, which are some of the most efficient carbon sinks, are in danger. The largest forest in the world, the Amazon rainforest, has been cleared out for agriculture practices, which are destructive. Most natural areas can keep absorbing tons of carbon from the air if they're protected with the cooperation of all nations. As a result of population growth, nations need larger lands for agriculture to feed the population. New forests with agroforestry systems can be planted to create rich and diverse forests that will remove tons of carbon from the atmosphere. Agroforestry is one of the best food production systems instead of destroying forests to clear land every year. Agroforestry is a farming system in which trees are grown among or around other crops. A combination of agriculture and forestry has multiple benefits, such as greater yields, increased biodiversity, improved soil, reduced erosion and carbon sequestration. In addition to that, peatlands, mangroves must be protected in every nation, while cleared forests are being replanted with reforestation projects. The same diversity of trees and plants must be planted to revive the original forests. Reforestation involves the planting of different selections of seedlings taken from the area, often multiple species. If the forest is replaced with one species of tree, all other vegetation is prevented from growing back. A monoculture forest similar to agricultural crops would hinder the diversity of the original forest. Mangroves grow in coastal saline or brackish water. They can revive coastal waters and house biodiversity. They can also clean the waters and remove more carbon dioxide than other forests. During 1 year, a mature tree will absorb an average of 22 pounds of carbon dioxide from the atmosphere. Forest protection seeks to prevent unsustainable intensive farming and logging, pollution of the forest soil, expansion of city developments, urban sprawl. Carbon removal, capture and storage, carbon capture at the source, direct air capture. Carbon capture and storage is the technique of capturing carbon dioxide before it enters the atmosphere, transferring it, and storing it for hundreds or millennia. CO2 is often absorbed from large sources such as coal-fired power stations, chemical plants, and biomass power plants before being stored underground in geological formations. To mitigate the effects of climate change, the goal is to reduce CO2 emissions from heavy industries. Carbon capture is more cost-effective when combined with a utilization process that uses low-cost CO2 to produce high-value compounds, chemical to offset the high costs of capture operations. CO2 may be trapped and converted into a range of compounds, including alcohols like methanol, which can be utilized as biofuels and other renewable energy sources. Other commercial commodities include plastics, concrete, and chemical synthesis reactants. CO2 is a viable energy transporter as well as a feedstock since some of these chemicals can be turned back into energy. In direct air capture, carbon dioxide is absorbed from the atmosphere and concentrated for sequestration, consumption, or the production of carbon-neutral fuel and windgas. Carbon dioxide is removed from the atmosphere when it comes into contact with chemical media such as an aqueous alkaline solvent or sorbents. The CO2 is then removed from these chemical media using energy, resulting in a CO2 stream that may be dehydrated and compressed while also replenishing the chemical media for reuse. Large fans are used in most commercial processes to force ambient air through a filter. They absorb CO2 from a gas with a liquid solvent, commonly amine-based or caustic. For example, sodium hydroxide combines with CO2 to form sodium carbonate, which is a stable substance. This carbonate is heated to produce a pure gaseous CO2 stream. Causticizing can be used to recycle sodium hydroxide from sodium carbonate. Alternatively, in the chemisorption process, CO2 binds to solid sorbent. The CO2 is subsequently desorbed from the solid using heat and vacuum. The idea of using several small distributed DAC scrubbers to achieve an environmentally meaningful reduction in CO2 levels, similar to live plants, has given the technology the nickname artificial trees in popular media. Other substances which can be used are metal organic frameworks. Semi-permeable membranes are used in CO2 membrane separation. This approach uses less water and has a reduced footprint. Agriculture and food, regenerative, chemical-free polyculture, soil health, agroforestry, plant-based proteins. Regenerative agriculture is a way of preserving and restoring food and agricultural systems. It focuses on topsoil regeneration, biodiversity enhancement, water cycle improvement, ecosystem service expansion, biosequestration, climate change resistance, and agricultural soil health and vitality. On small farms and gardens, regenerative agriculture is frequently based on ideas such as permaculture, agroecology, agroforestry, restoration ecology, and holistic management. Large farms are less philosophically driven and frequently utilize no-till and slash or reduced-till strategies. In regenerative agriculture, the capture of atmospheric carbon dioxide by growing plants that move that carbon dioxide into the soil, primarily through the cultivation and nurturing of forests and permanent perennial pastures and grasslands, is nearly the only currently working technology for drawing down greenhouse gases already in the atmosphere. Polyculture is the technique of cultivating many crop species in the same location at the same time in agriculture. Polyculture aims to emulate the variety of natural ecosystems in this way. Polyculture, also known as intercropping, is the polar opposite of monoculture, which involves the cultivation of just one plant or animal species. Organic farming, also known as ecological farming or biological farming, is an agricultural approach that emphasizes crop rotation and companion planting while using organic fertilizers such as compost manure and green manure. Organic agriculture is an integrated agricultural system that aims for sustainability, soil fertility improvement, and biological variety while avoiding synthetic pesticides, antibiotics, synthetic fertilizers, genetically modified organisms, and growth hormones, with few exceptions. Permaculture is another method of land management and settlement planning that mimics the pattern seen in healthy natural ecosystems. Agroforestry is a type of land management in which trees are planted near or among other crops. This agroecological succession, similar to that found in natural ecosystems, is triggered by the diversification of the farming system. Agroforestry is similar to intercropping in terms of principles, but it may also encompass considerably more complicated multi-strata agroforests with hundreds of species. Enhanced yields from staple food crops, increased biodiversity, improved soil structure and health, less erosion, and carbon sequestration are all benefits of combining agriculture with forestry. Better nutrient and carbon cycling, soil water retention, biodiverse habitats, pest, disease, and weed management, and soil protection from water and wind erosion are all examples of agroecology applications. Plant-based proteins are made from vegan ingredients, eaten as a replacement for meat. Plant-based and fungus-based alternatives, such as tofu, tempeh, and textured vegetable protein, are often created using soy. but they can also be made with wheat gluten, pea protein, or mushroom mycoprotein. Growing these protein crops is more sustainable than meat, which is harmful to forests and animals. They can also provide health benefits when they're included in plant-based diets. Growing crops in a diverse setting to produce plant-based proteins can reduce carbon emissions related to animal agriculture. Forests are destroyed to clear land for animal agriculture. Plant-based proteins can prevent that if they're adopted worldwide. Plants absorb carbon dioxide, which is a greenhouse gas contributing to climate change. If most of the world's population switched to a plant-based diet, carbon emissions and deforestation as a result of animal agriculture could be minimized. Growing new polycultures, as in intercropping and agroforestry, can sequester tons of carbon and can provide a variety of plant proteins and healthy foods. There are so many protein-rich crops that can be grown with agroforestry systems that can either restore, reforest degraded, deforested lands or create new ones in vacant lands.